Hello friends, in this question we are asked to find the value of the resistance R, okay, and the given voltages are VAB and VBC, each 100 volt, and also the input voltage VAC is given to us, okay, so VAC is also 100. So these are the RMS values, okay. So let us see how to find these resistance value, okay. So here what you can do is you have three voltage phasors, okay, because this is a AC circuit, okay, which is a 50 hertz circuit. So all the voltages may not be in phase, or they will be displaced by some phase angle, okay. So let us first decide one of the voltage as the reference voltage, okay. So I'll take VAB as the reference voltage, okay. Now VAB is my reference voltage, okay. So if you see this VAB, across VAB, the circuit is capacitive in nature, okay. So the current which is flowing, say this current is I, which is 5 amps, okay. This is going to be leading in nature with respect to VAB, okay. So let's say that it makes an angle theta. So this is my current I, and this makes an angle theta, okay. Now you can see here that this current, same current, flows here across this inductor I, okay, and with respect to the voltage VBC, okay, this current should lag by 90 degrees, or this voltage VBC should lead this current by 90 degrees, okay. So I just make a VBC which is 90 degrees leading to current I, okay. Now when we have this information with us, what else do we have with us, okay. We also know that the input voltage is VAC, okay, and that is 100 volts. So our VAC should be equal to VBC plus VAB, okay. So this is here these voltages are adding, but they are not simple algebraic addition, so it will be vector addition, okay. So this is KVL, okay. You can say this is KVL in case of an AC circuit, where you have to add vectorally, okay. So now you know that when two vectors are displaced by some angle, what is the resultant value, okay. So here the angle between VAB and VBC is 90 plus theta degrees, okay. So what will be the resultant voltage? The resultant voltage is VAC, and that is equal to under root of VAB whole squared plus VBC whole squared plus 2 into VAB VBC into cos of 90 plus theta, okay. Now here we know all the values except the value of this theta, okay. So if you calculate this VAC, we already know it is 100, is equal to under root of, this is also 100, so it is 100 squared plus 100 squared, okay. This is also 100 plus 2 into 100 into 100 into cos of 90 plus theta, okay. Now if you solve this, okay, you get your theta as 30 degrees, okay. So the current leads this voltage phasor VAB by 30 degrees, okay. Now let us just concentrate on this phasor, okay. So this is my VAB, and this is my angle, this is my current I, and this is my angle 30 degrees. Now this current again will be divided into two components, which is IR and IC. IC is the current across the capacitor, and IR is the current across flowing in the resistor. Now the current IR will be in phase with VAB, okay. So here the component of I which will be in phase with VAB is IR, okay, and the one which will be leading VAB by 90 degrees, it will be IC, okay. I need IR, okay. So now my IR is equal to I cos 30 degrees, okay. So now this I is already given to me, which is 5 cos 30 degrees. Okay, now what advantage do I have after calculating IR? I already know the voltage across this resistor, which is VAB. I know the current IR, so the ratio will give me R. Okay, so my R is simply VAB over IR, which is 100 divided by 5 cos 30 degrees. Okay, so this is the value of R. Okay, and if you calculate this, it comes out to be 23.09 ohms. Okay, so this is the value of R. Okay, so here only the way to solve this problem is just we have to know which phasor we have to take as reference. Okay, so that we are able to achieve the result we want. Okay, so thanks for watching.